So here is some dependent hypothesis. So the null is always there's no difference. So in this class and generally when you do a dependent t-test, it's always going to be that the population mean of different scores equals 0. So it could be something different than 0, but more likely than not, the null is going to be that there's no difference. And if there's no difference, then between the first person in the pair and the second person in the pair, then you're going to get an average of 0. So if everyone's exactly the same, then you're going to get an average of 0, and that means that there's no difference. But we're trying to prove this wrong, and so our alternative could be one of these three things: that the difference score is less than 0, the difference score is greater than 0, and then the difference score is just not equal. So we say that there's a difference, but we don't really say in what direction. So we have to remember how we subtracted to pick this. So I want to say that having both is better than just the couples only. So I would then pick the greater than, because how we subtracted. So we did both minus couples only. I think both will be the higher in happiness. Remember, this is happiness, so bigger numbers are better. You need to know what your outcome is when you're considering this also, because if it was sadness or depression or something, we would have the opposite. But in this case, it's happiness, so high numbers are good. We think that having both types of counseling is better than having just the couples only. And we did both minus couples only, so we think the both is a bigger number minus a smaller number. So we're going to get a positive number, and a positive number is greater than 0. Okay, so in this case we would pick the mu d is greater than 0 because we think the both is better. Now, what would happen if we did couples only minus both? So we're switching the way we subtracted, so that would mean that we would actually have mu d less than 0 if we change the ways that we subtracted. Now it doesn't matter which way you subtract, but you need to be consistent with your hypothesis, okay? Now I'm going to talk about the independent t-test hypothesis. So the null hypothesis is that there's no difference between the population means. Remember, in the hypothesis, we're always talking about the population, okay? Because that's what we're really interested in. So so the null in this class anyways, and for most, if not like 99% of the time, people are going to hypothesize that for the null, that the difference between the two averages are equal to 0. So for independent t-tests, remember we have two separate population averages instead of just one difference or average of different scores. So now we have 2 instead of 1. That's why the hypothesis looks different. So we have in this case we had the population average for counseling, so that's why there's a C, minus the population average for no counseling, and that equals 0. So that means if they're equal to each other, then this difference will equal 0. Okay? And then when you're calculating the p-value, this what goes in the middle as well. If you're making the normal distribution, if you're drawing it out, the 0 goes in the middle, and the same thing for the dependent t-test. And then we have alternative hypothesis or the research hypothesis, and there's 3 choices: less than, greater than, or not equal to 0. And since we wrote it this way, we did counseling minus no counseling. If we did that and it was less than 0, that means the counseling would be lower because we have a small number minus a big number. If we do counseling minus no counseling and it's greater than 0, that means we have a positive number. That would mean we have a big number minus a smaller number, so that means counseling would be higher. And then if we have a non-equal to sign, then that means either the counseling is higher or it's lower. We're not really saying which, but we're saying that there is a difference, so it's one of the two. In this case, I'm going to predict that the counseling is higher than no counseling for, say, their happiness scores, and so that's what I would pick for the alternative in this case. Now, if I wrote it the other way, and I said that we did the population average for no counseling minus the population average for counseling, then I would actually pick a less than sign. Okay? So it depends how you write it. Doesn't matter how you write it, either way is correct, but you need to know how you wrote it and pay attention to how you wrote it. It doesn't matter which way, but you have to pay attention to how you wrote it so you can pick the right sign. And then when you go to your test statistic, when you make your test statistic, you have to subtract in the same way. So when you go and do your you're subtracting your samples averages from each other and the test statistic, you have to do it the same way you do your population averages in your hypothesis. So it doesn't matter how you subtract again. You can do it either way. Either way is correct, but you have to be consistent to be correct. Okay, so if your hypothesis is one way, then when you subtract your sample means you have to keep it the same way as well. Okay? And that ends this lecture.